Okay, our recording is on, and you're welcome to tonight's session on data annotation. This should be our third session on data annotation and this bootcamp. So this night we're going to look at what we call multimodal data annotation. Yeah, multimodal means it's going to be different model. It's not going to be one model. Going to different model of annotation we're going to look at. Most of these language models, so many of the language models specialize in one model. When we talk about model, we talk about a particular domain, like text domain. Some AI specializes in text. You can call it text model. Some specializes in image. You can say it's image model. Some specializes in video. So you can see it's a video model. Some specializes in audio. We say it's audio model. But when we talk about multimodal is a combination of both text, audio, video, images. So we're going to look at all these four types of annotation. So we're trying to be fast because of what we have, try to see how far we can go and see if we can wrap up this annotation class as soon as possible. But let's proceed.
Check is inside there.
Okay, I hope you can see my screen.
Yes, sir, I can see it.
Okay.
Lisa, can you increase the font a little?
But this is the much I can do for now. It's going to be inconveniencing for me if I increase it a little now.
It's okay, thank you.
Yeah. So, like I said, we are going to look at multimodal data annotation. So, like I said, data annotation is not limited to one type of information. We have different information. We are annotating data. Data is information, processed information. So, the information is a processed data. So we're looking at different types of data structure. What are they? We have some text, we have some in images, we have some in audio, we have some in videos. We'll try to see how the raw data is going to look like in each of these. And if we duly annotate it, how is it going to look when we use like Label Studio, all these annotation tools we're going to use. From tomorrow, we'll start talking about tools and looking at the tool we're going to use for annotation. So we're going to look at, this is the original data. After annotating the data, how is it going to look like? Yeah. So AI models will have text, images, audio, and the videos. So that is primarily what we're going to do. How do we label all this data in these both models? So in AI, something you have to try to cram is what we call model. Starting from machine learning to wherever we might get to AI, you must understand model. Yeah, in AI, instead of calling app, we call it model. I want you to understand when you say model, you understand what model means. You can call it applications, but this time we're calling it model. So we don't talk about video model, we're talking about AI video app. We're talking about text model, like ChatGPT. You see, it can process text. ChatGPT can process images as well. It cannot create videos, but because it has the capacity to process text and images, we call it multimodal. If you go to Google Gemini, Google can process text. Google can process images, and Google can process videos. So we call it multimodal. So some of them you find out they can only create only text. They can't do anything outside text. These are single model. But AI industry has gone beyond single model. So we train different models. All this data annotation is to train this different model on different data set. For those who are using images, we train them on images and the rest of them. So we're going to take it piece by piece, one after the other. We're going to take text annotation. How do we transform raw text to process text ready for usage? Text annotation is the process of adding label, categories, entities, and or structured information to written language. When we write a language, AI do not understand it just like that. Throughout our journey, introduction and others, we try to go deep, a little bit deeper this time around as professionals. We are not just trying to understand it just like any other person who is just hearing data annotation. We want to see how we go a little bit deeper to understand this annotation. So normal statements, text, if you give it to AI model, they might not just understand it. For AI to understand it very well, you need to add label, you need to categorize it, you need to create it as entity. Any of this, you need to break them down so much. So this annotation, they are used in chatbots, customer service, search engines, sentiment analysis, and document processing, and even content moderation and natural language processing. Now, this is the beautiful part of it, natural language processing. This natural language you see here, this is the reason, let me use another marker, because I want us to understand this, talk about natural language. So, this natural language processing is extremely important. It's because we train model very well on data, which is text, mainly text. That's why you can put a simple text and AI will develop a full source code that will help you to create a mobile app. You don't need to put any code, any programming language, no language, no code. All you need to do is put in your natural language. What is natural language? Natural language is our mother tongue. This language I'm speaking to you now is what we call natural language. It's not a code. But in today's era, they have taken away this difficulty of trying to code before a machine can understand you. It's because we train these models very well on different statements, different texts. It's very, very important. That's why you type and you see ChatGPT will just go get what you want and give it to you. Just normal text. It's because we have been training them using natural language. And now they can understand natural language very well. So to do this text annotation, we start from classification. We need to classify all these texts. When we just write it, we don't just give it to AI. My name is Charles. You might not understand what that means. You need to classify it. You need to garnish it so that you to understand it. So text classification assign entire piece of text to one or more predefined classes. Any text, let's say a statement or a sentence, it must belong to a predefined class. It must have a class. That's why you classify it. Where does it belongs? Example of a text. This is a text. It's a statement. A text can be a statement, can be a full sentence, it can be a phrase. As long as it's written, we call it text. That's what we call it, text, written. Okay, see, I want to cancel my subscription. It's a text. It's a statement. AI might not just understand this. If I want to use this to train AI, you must have to give it a class. A class, we might create different classes. Like say here, a class can be cancellation request. You want to cancel, so you call it cancellation request. So if you come to an organization, you might have different types of classes. If you want to train AI, chatbots, we will have different types of classes. So we give this, assign this class to this particular statement. We have other classes we can create so that if we want to assign a class, we might select, we might create a drop down and select one particular class when we want to assign a class to a statement. So these are how possible classes: email classification, support ticket routing, document classification, and spam detection. But all of them belongs to different classes. So this particular statement here, I want to cancel my subscription. It belongs to cancellation. That is where it belongs to. We cannot say it belongs to document classification, or we are not going to assign spam detection to it. So we can assign cancellation. So if you are training a model based on predefined classes you have, when you are starting your training, you must create a predefined classes in the model. So model, this is the logic. Model will know that any statement coming in, it must belong to any of these predefined classes. And with that, the model should be able to understand what that particular message or that particular text needs. If a text is coming in and it doesn't have that kind of classification, it doesn't match any of the predefined classes within the model is not going to understand it. So that's why we have classification. It's not only this, we have another thing we call sentiment. We assign sentiment as well. Then we can tell a model when something sounds like this, it means positive. When a statement sounds like this, it means negative. Now, sentiment, we are building the model to be a bit sentimental, a bit emotional. That is what we are building a model, sentimental, to understand the way we feel, to understand the way a sentence feels. Sentiment annotation identifies the emotion, emotional or opinion-based tone on the text. Models do not understand anything emotion. Is where they are going to tell a model, this is the way something feels, how this is the way we feel about emotion. We can be negative through this way, we can be positive through this way, we can be happy, and we can be unhappy. So, every statement must, not every statement though, but we can equally train a model on a sentimental aspect of some statement or text using positive, neutral, and negative. Example, your service was fantastic. Model cannot understand this until it's, if you train a model that this particular statement is neutral, this is what the model will understand. It does not understand it automatically. It's based on the way we train it, the model, is the way the model is going to behave. So this thing we are talking about here is just like a child. The way we train a child, even the Bible said, when you train it, the way you train a child, when they grow, they will not depart from that way. The way that is the concept we are using to train this AI. After training them this way, any day they see this kind of statement, they will know that it is positive. Like now we assign positive to it. So if you are chatting with AI and you say your service is fantastic, AI will automatically understand that you are praising him or it and say, oh, thank you, I appreciate. You know that once you say that, the next thing, oh, thank you, I appreciate that. That's a kind word. AI say that a lot. If you want to doubt what I'm saying, when AI finish doing a work, just try to generate something through ChatGPT. And when after generating, tell ChatGPT you did a fantastic job. You see, ChatGPT might respond to you, oh, thank you, that's a kind word. There's no way ChatGPT will understand and say that's a kind word. It's because ChatGPT has been trained that fantastic service is a positive is a positive label. So you see, this one is positive. The delivery was delayed. The delivery was 2 days late. You see here is negative statement. You see the person writing this is not happy. You know, he's not happy because it's delayed. And we can assign while training, you see that is negative. So we have to assign sentiment while we train AI. And that's how they understand all these things. We communicate to them when we're happy, when we're not happy, when we feel positive or negative, or when we're just neutral. Intent classification, another intent classification in text. Intent means intention. What is the intention? The purpose. The intent classification identifies what the user is trying to achieve. Like I said, what is the purpose? What is the objective, the goal, the intention? That is intent classification. We try to let AI know our intention. Anytime we come in, we start typing or we send a request, they should be able, when they read that text, they should be able to understand what we try to achieve. We try to achieve that by training AI on text intent classification. We class this all this text through classification called intent. Example of this: how do I reset my password? The intent is password reset. Please refund my payment. Refund. Intent here, you want the refund back. So these are the ways to classify various intention. Every statement must be classified very well. Intent classification is important for chatbots, virtual assistant, customer support system, and automated routing. All these things are AI agents. You see, AI agents, why is important we train AI on this? This kind of knowledge, you don't really need to work with OpenAI to know this. If you are, for instance, if you are working with Zenith Bank, and Zenith Bank is planning to build a chatbot that can, a agent. Yeah, you are here going to use this kind of classification to train that AI agent on how that AI agent is going to be responding to customers. If customers are using that AI agent you created to be chatting, it's different because of the way you train that agent is different when another person is using ChatGPT to understand informations and how Zenith Bank work, because you train their own in a particular way. So it's extremely important. We communicate this time around with AI through text, not image, not through video. It's through, so text annotation is extremely important. It's highly used. So if you train AI agents on this, AI agent can chat, customer can chat AI agent, and AI agent will understand what the customer is saying and then know, for instance, say, I want to reset my password. AI agent will just direct, will understand what the customer is saying and direct the customer to documentation, knowledge-based system where the customer can read up how to reset a password. And if it's not there, it can direct the customer on the appropriate email or appropriate telephone number, or it can equally contact the right customer support to support the customer on how to reset password. So this is why all these are very, very important. So knowing all this doesn't necessarily mean we must go and use it to train big models. We can equally use it to train small model like chatbots, virtual assistant, all these small AI agents, which we are going to equally create. By the end of this bootcamp, you should be able to know how to create an AI agent that can work for you. Be able to know how to create even a project manager agent, or business analyst agent, or even customer support agent. You should be able to build that. Topic classification. Topic classification identifies the main subject being discussed. Example, mortgage interest rate increased this month. So this here under this topic is classified under finance and mortgage. The latest software update caused the application to crash. So the topic is technology and software. So this classification is just like when you are building a website, or for instance, you are building a blog system. You need to do classification so that all the blogs, if you want to write a blog, you need to select a particular classification so that people going through your website will understand different categories. This is just what they are doing. Classification is another word you can use is categorization, categorizing it, labeling it, tagging it. Name identity recognition. Named entity recognition identifies and categorizes specific entities appearing within text. If there is entities appearing in a text, then it helps us to recognize different entities within the text or organization. Common entities include a person. When you are writing a text, we might use somebody's name. The person is living in Lagos or Abuja. The person is working in Fidelity Bank, and so. So, as you are writing, you are mentioning different names. So we need a situation where the model should be able to understand recognize different entities. Example here, we say, Sarah works for Microsoft in London. If we need to annotate this using this, we see we have a person here, we have organization here, we have location here. So we should be able to identify that the person who is here in this statement is Sarah. And we should be able to understand that Microsoft is the organization here, and location is here, London. So if we do the classification very well, the AI should be able, when you see this kind of statement, you should be able to understand the person involved, the location the person involved is in, and the organization the person involved is working at or is at the moment. Then we have, this one is for recognition, to recognize entity, named entity. Then we have entity extraction. Entity extraction identifies important piece of information from the text and convert them into a structured field or a table or a structured data set or organized data set. So recognize the entities there and use it to create a table. So in this, you see my order 45821 was delivered to Manchester on Monday. This is a statement. This is a text. We can convert this text to a table and it will look more professional. But AI cannot convert it to a table if AI do not understand this statement. If this statement is not well annotated, or if AI is not annotated or trained to understand this kind of statement, there's no way AI can be able to convert this into a table. But with this kind of, because AI is well trained, it can just extract this and put them in different fields and assign value to different them. So you see here, AI is now have extracted the information from this and use it to create a data set. And this data set, you see the field and value. And under the field, we'll have other number, we'll have location, and we'll have date. And here, the value is, order value is here, 45821. Location, Manchester. Date, Monday. Yeah, so all the time you tell AI, I want to do this, create a table for me, do it in a table. There is no way AI can do all these things. The only way AI can do it is because AI is trained on entity extraction. That's why we are training AI in a lot of things. So the AI is doing a lot of work, office work. It's not because AI is a must, it's because we train them. This is how we get them to where we are today, to start doing one or two things, because we train them this way. We label this statement. This statement, we annotated this statement as, to be able to recognize this statement and do some extraction, recognize and extract. So you can see this, we can combine this entity, name entity, after name entity extraction. Once it recognizes, it can equally do extraction. We equally have relationship annotation. This helps AI to understand relationship, correlationship. Relationship annotation identifies how two entities are related, connected. Example, Ada works at Zikura AI. Zikura AI. I don't know if you guys know that we have a company called Zikura AI. We have our own AI. which is quite old. Zikora AI should be like 3 years now. We started doing something at scale. So, and here you see Ada works at Zikora AI. And here we have the entity here, entities, Ada person, Zikora AI organization, then relationship, Ada works for Zikora AI. So these techniques can support knowledge graph, research database, and enterprise information. So we train AI equally on relationship, and it's very, very important what AI is doing, because when AI understands the relationship like this, AI can equally use it to create table, that is knowledge graph, research database, that is the purpose. Even in enterprise information extraction, AI can go there, extract information, and modernize it for us to use. Even in data analysis, very, very important. We equally have question and answer annotation. Question and answer help us to understand relationship between answer and question. Whether a question, whether this answer is good enough for this question, or this is not good enough for this question. Now, you've seen that things are changing rapidly. How many of you have had interview with AI agents? How many of us? Job interview. Have you had a job interview? Okay, Vivian, how did it go? Where did it happen and how did it go?
So this they call it micro one. So it was actually asking me questions, and although when I answered, anyone answered, did you say it was wrong? All right, just say okay, that is good. The next question, okay, that is good. So until the end.
Okay.
Of the interview.
Yeah. So yeah, the point here is it might not tell you whether you fail or not, but it can understand maybe to select you for the next interview. You know, most of the interviewers, they are not going to tell you you fail. If you need to move to the next level, or if you need to be selected, you will get a job offer, or you get an email to congratulate you or tell you, I'm sorry, we're not proceeding with you. So it might not tell you, but the point I'm making here is that when you are having this kind of interview, it understands what you are saying. It knows, based on the question the AI asking you, it can understand whether your response to that question is good enough. There is no way AI can do this except through question and answer annotation. I can't remember how many times they call me on phone, AI, you know, we talk on phone. I know it's AI. You have a serious, I've had 1 hour interview with AI on phone. And you don't play around because it's AI. Because AI has been, they've given AI the mandate. If you do well, you get the job. If you don't do well, you're not gonna get the job. You not say you are laughing or you're playing around because, yeah, no. So when that's what I'm saying, that things are changing very rapidly. It used to be only phone, but things have changed that now we're having video interview with AI. AI is monitoring you, the way you comport yourself, AI, visual recognition, this part, body language. If you do if AI feel like you are cheating, or maybe you are reading from AI, the way you turn your head, the way AI will understand if you are cheating or not. So these are advanced level of question and answer annotation. Yes. There's the point I'm trying to make. Question and answer annotation. And there are so many, it's bigger than what we just think it is. Because they are training AI now that even the entire job selection process, the human resources team, you might not see human human in the loop, or it might just be only human in the loop throughout the whole evaluation. So things are getting a bit more advanced with this AI. But what we do, we key in. So question and answer annotation creates or validate relationship between question and answer. You know, question and correct answer. Example, context. London is the capital city of the United Kingdom. Question, what is the capital of the United Kingdom? If you said New York, if AI is doing an interview, then know that you failed. So during question and answer annotation, or if AI is carrying out that kind of, we have what we call context. Context engineering is part of what we are going to do. So in a situation where AI, you're having an interview with AI, the context that the AI is going to base during that interview is going to be a CV and job description. What is that job description? What is the job saying? Then what is your CV? So AI cannot go outside this information. That is the context. AI cannot go outside when it is in your CV that you are a project manager. AI cannot go and start asking you information as a medical doctor. If you say you worked in Microsoft, AI cannot go and start asking you information about the school, the secondary school you are teaching, because it's not part of the context. It only comes from context and then the question and answer. The question and answer is going to be evaluated looking at what the context. The question is going to be drawn from the context, and the correct answer is equally going to be validated from the context. Yeah. So it supports question and answer model, reading comprehension, AI assistant, and evaluation database. Conversation annotation. Conversation annotation labels interaction involves multiple messages. Possible annotation include speaker, the intention, which is the intent, sentiment, topics, resolution, conversation, message, and escalation. So these are all the things that can be annotated when we're looking at a conversation. Example, my card stopped working. You can say the intent here is card issue. An agent, I will help you investigate this. Conversation stage, support response. So if you have a message, or now they give you WhatsApp screenshots for you to annotate. The only way you can annotate it very well is to use this kind of annotation labels like speaker, intent, sentiment, topic, resolution, conversation, and escalation. So this will help you to annotate a text, a conversation text. Toxicity and safety classification. This helps us to understand toxic, content. Toxic content. That's why some algorithm, when they see this kind of in social media, they will flag it off. It's because AI is trained to understand toxic languages. If you come to our platform, almost all the platform we're building, like autonomous community we're building, there are some words we are classified under kind of algorithm sensitive. Such languages cannot be used in that platform. If you use such words, you can't be able to send a post or chat if you use such words. So that's how it's part of the AI ethics. These are a very serious topic in AI governance. Toxicity and safety classification identify the content that may be abusive, threatening, hateful, harmful, unsafe, sexually explicit, otherwise inappropriate under defined policies. So this is very, very important aspect when we are talking about AI safety and AI governance, AI ethics. Example, text may be classified as safe, toxic, harassment, threat, hate, and other safety categories. Safety annotation must follow clearly defined guidelines because interpretation can vary substantially between annotators. But know that this kind of is extremely important. Toxicity, is a very big topic in not only in AI, but generally in our society. Even if outside AI, even outside social media, even in the physical world, even in videos, even in television. That's why if you see, if you watch World Cup, you see most of the players, if they want to talk to one another, you see them, they do their hand like this in their mouth. It's not because their mouth is smelling. It's a policy these days. When you want to talk to somebody in public these days, you do your hand like this, it's becoming a culture. Do you know the reason? Can anybody tell me the reason why you do your hand like this when you talk? Even when they are videoing you? Or anybody? Okay, Mr. Ophelia, I thought you want to help us.
Okay, they actually close their mouths. Good evening, everyone. They close their mouth because to avoid lip reading.
Okay, I hope you close their mouth while you are speaking with us.
So, but recently FIFA has banned them now. So because of high cases of people saying they're racially abused and all. So now, if you close your mouth, it's I think almost a red card or so. It's actually an offense now when you're talking to
Yeah,
other
but
people.
if you look at it, most people still close their mouths, because
Yes, yes.
I don't think, for me, I don't think is because I've seen so many people, they say something, they started reading it. I remember the issue of there's one time John Terry had such an issue. John Terry said he didn't say fuck, but they started doing the lip reading. They said the lip twisted like he said fuck. But nobody heard what he said. He just do like it. But some people say that he swore and he was saying fuck, but he said he didn't say fuck. These days, instead of all this drama, if you want to talk to someone, you just do like this. So the point I'm trying to say is that toxic statements is extremely safety against toxic statement is not something the society tolerates. So you don't play around safety or regulation or governance against toxic statement. And we equally train AI. As a matter of fact, AI is very sensitive on this kind of matter. You find out that AI will tell you that it's not gonna do what you ask because you feel that, or this is going to tell you a reason that this is against their policy. Yes, there are some certain things the AI will say no. Like, for instance, now you can tell ChatGPT to create an image of a stark naked woman. It's not gonna agree to do that. Yes, it's not. Only if you walk, there's a way you can, even if depend if you tweet your prompt. I don't think you can even twist your prompt or that will bypass that. Although there are some special AI that is even creating pornographic videos and images, yes. But these are some of the AIs that are not regulated. A very good, high profile, respected AI company cannot tolerate that. They will not allow their AI to create all this kind of toxic content. It's not, because they are taking this toxicity and safety classification extremely important. They train them very well to understand this. So, text annotation summary. So with what we had already, we've gone deep into text annotation to understand text annotation. So in summary, we have techniques and main questions. Under this, we say text classification. What class does this text belong to? So if we are growing to become a professional annotators, we should be able to understand any sentence or any statement, or any text, we should be able to understand where they belong. You know, sentiment, we should be able to understand the sentiment. How does the writer feel? You know, these days we are writing fictions. AI writes fictions, movies. It is through this sentiment that AI can write a movie and give sentiment, feelings, the way people feel, their tone, and things like that. Intent. What does the user want? What is the purpose? What do they want when they are creating that statement? You know? Topic. What is the text about? This is very, very important. Even some intelligent officers, police intelligent officers, or even military intelligent officers, or the security agencies, these kind of things are things they need to understand well, because they should be able, they have what called text analysis. They analyze it. If you make a statement, after making a statement, you want to analyze a statement, what happened? Or if there is something happened and they have somebody's phone call, messages, they can read the message, analyze it through this to understand what happened. Now, which name entity are present? Extraction, entity extraction. Which specific field should be captured? Relationship annotation. How are entities connected? Question and answer. What is the correct answer? Conversation annotation. What is happening within the interaction? Safety classification. Is the content safe or harmful? So now we'll have this here, example of text annotation, how when a text is raw and when it's labeled. Like you see here, labeled, that is raw text. Unlabeled, non-labeled, that is raw text, and label. So if we read it very well, we should be able to understand. From 1 to 5, here is not processed. After processing it, this is how it looks like, which I want you to pay more attention, give it a closer look. Yeah. If you need the images out of this, I can send it so you examine it very well. So that by the time we are going to be doing it practical, there is no other way I'm going to teach you, or there is no other template I'm going to provide with you. when we are going to do it practical. Because we might, when we get into Label Studio or any other technology you might be using, do not think where there is any other special template. This is a template. Looking at this, you should be able to see how raw text and how label text. You see here, every text here is assigned the intent, is assigned the sentiment, is assigned entities, is assigned priorities. You can equally assign more based on what we've learned here. But this is it, all of them here. So this closes the chapter of text annotation. Now we are going to step into image annotation. Image annotation is the process of adding labels or visual markers to image so computer vision system can understand their content. Common applications include autonomous vehicle, medical imaging, security, retails, manufacturing, agriculture, facial and object recognition. Image classification assign a label to the entire image. Example here, image of a dog, and then you label dog. Image containing a damaged product, and then damaged product. The question is, what does this image represent overall? So we try to use a box to capture image in a box, and we assign it a particular label, a name, and that is what you see. What is in that box, that is what is that image. So if it's a dog and we assign or give it a name as a dog, that is how it's going to be. Boxing, bound boxing. Bounding box is a rectangular box drawn around an object. Example, an image container. One car, two pedestrians. Annotator draws a rectangle around each of these assigned labels. So in this image annotation, the way you do it is you are going to draw a rectangle around the image and you assign a name on it. That is the way we annotate images. Typical output can be bounding box of a car, a pedestrian, and another pedestrian, which we are going to see very soon. So that is how we annotate image, just assigning label, giving it a name. It's not like text that we can try to add a lot of even emotion and a lot of things. It's a bit simpler than text, and the text annotation is more complex than image annotation. Polygon annotation. Polygon annotation creates a more precise outline around an object's actual shape. Rather than drawing a rectangle, the annotator marks several points around the object. So instead of you trying to just create a box around, then you pick different key points. You might just pick head, pick shoulder, another shoulder. You touch it, like if it's an image of a human being. You might decide that instead of you just creating a box around a human being, you start picking key points. You pick a head, you pick shoulder, then you can then go down and pick the foot. And it covers almost, if the person's hand, you might then pick the hand as well. So covers every different section of the person. Useful where object shape matters and objects overlaps or great precision is required. Okay, I want to ask a question here because it is through this that they created this kind of app. Have any of you used Microsoft Lens, this app for scanning? How many of us know Microsoft Lens? Microsoft Lens is free. You know, if you don't know about it, it's free. For instance, if you are scanning your documents, if you want to scan a document, it's a product of Microsoft, it's a scanner. As a matter of fact, since I discovered this app, I have a photocopy machine in my house here, in my office here. I have a very beautiful photocopy machine, but I don't use it anymore. All I need to do is just, I don't need to start, snapping like a lot of us. It doesn't look professional. When you want to send a document, you want to send me a degree certificate, you snap it and send. If you want to make it more professional and to put it in PDF immediately, just use Microsoft Lens. The Microsoft Lens, even if you put the object in a table, when it looks, it tries to recognize the main object. It knows you are trying to scan a particular object. It will try to pick different points of that particular object. That is what I'm trying to explain. Polygon annotation, picking different points of that document. You make sure that all the documents, all the points are connected. You see the way it's trying to connect a different edge of that object, and then you snap it. It captures the exact object from the table. It's not going to snap the table. The other spaces outside the table is not going to be captured. This is part of object annotation. That particular app is trained to understand and pick objects. So does it mean none of us uses Microsoft Lens? That's yeah, I'm not trying to make marketing for them, but it's a very beautiful app. If you go to Play Store, yeah, very, very beautiful. I use it all the time.
I know about the Microsoft Lens, but I've never used it because I use Scanner.
Okay. Yeah, I use Microsoft Lens. Is extremely professional. So, but if the cam scanner, if you're trying to scan, you see the way you try to, I don't know, it picks different points. And by the time you scan, you find out that it's discard all the objects. It's not like it scans like a box or everything. No. So you just pick the exact object. Very, very useful. Example, rounded boundary, buildings, irregular object, and medical structure. So that is where they get this kind of inspiration, and they trained that particular app. All these apps, this is how they train them to work. All the app you see application, most of them are trained. Most of them who are AI. They are trained, not only AI. So many of the code is a logic. That logic they use, this is what they use in all this labeling and making sure that when they label an object, we don't capture other unwanted objects. Semantic segmentation. Semantic segmentation assign a class to individual pixel within an image. Example, road to road and sky to sky, and vehicle, in a wider vehicle, pedestrian to a person. So try to assign a class to individual pixel within an image. So for instance, we will have a very big image here, image containing different objects. We try to pinpoint different objects, smaller object within the overall image. That is it. That's what we do with semantics. So for instance, if we have image containing road, sky, vehicle, and pedestrian, so we should be able to label each person within a particular image. So it's not just like one image name. So we have different objects within the image. So we use semantic segmentation to label them, making sure that all the images or all the objects, let's just say all the objects within the image, the big image or the entire image, is being labeled. So you know what is going on in that particular image. The storyline, you can tell a story in an image by labeling all the objects within the image. We call semantic segmentation. Instance segmentation. Instance segmentation goes further. It separates different individual objects belonging to the same class. So, example, 3 people in an image. Person 1, person 2, person 3. So, if we have assigned a class of a person in an image, I say person is a class, and we have 3 persons there. You know, that person might not really be enough for us to understand the image. We can have a person woman, or you can have a person, let's just say a person child, person adult, and person elderly. So you see here we have 3 persons in that image. If we just use person to label that image and say person, AI might not be able to understand it very well because we might have more than one person in an image. So does it mean that whenever you see object of a person, or you see this kind of person, so if you see an elderly person using a walking stick, we see that it's an elderly person. We can use this kind of instance segmentation to say elderly person. Then if we see adult person within that image, We just putting a young man putting hands in his pockets. We might just say adult. Might just use adult, to do the segmentation. Then we'll have a child crawling or sitting, a toddler. We might then use a child or a toddler or a baby. These are three persons. That is segmentation. When we segment them, differentiate them in a very unique label, is going to go further to help AI understand better. So we use instance segmentation to do this. Okay. Key point annotation. Key point annotation marks important points on an object. Example, eyes, like I've said earlier, in this one equally, we use key points. So key point is going to pick up different important key areas. For instance, we want to AI to understand the key point in a human being or key areas. You can say we use key point annotation, pointing at different, like eyes, shoulder, elbow, knees, and facial landmark. It's commonly used for pose estimation, movement analysis, facial analysis, and sports analysis. So that's the way we use key point annotation. We use it to pick key points in an object. When we mean kind of labeling an object. Object detection. Object detection combines object identification plus object location. The system must determine what is the object and where is the object location. So with this object detection, we'll be able to detect where this object, like say you see, what is this person? Detect where you must understand what the object is. For instance, this is a car in the streets of central London. It now detects exactly this car is. This car is in the streets of central London, and this is a car. This is an object, a human crossing a road. Location can be a road object. So this is what we can do with object detection. We need to label object very well if we are trying to help AI detect object. We use object detection. Image annotation summary. Under the techniques we use image classification. The purpose of these techniques is to label the image, label the entire image. Then we use bounding box to locate an object within a rectangle. And we use semantic segmentation. We use polygon to precisely outline an object. And we use semantic segmentation to label pixel by class. We use instant segmentation to separate individual objects. We use key point annotation to mark important object points. And we use object detection to identify and locate objects. So if now they are trying to search where this particular object is, they can use even this CCTV camera, they capture, they want to analyze, and use object detection. Or if they go on satellites, they are looking for Osama bin Laden, looking at the structure of Osama, they can use object detection and detect that this is the exact hitting of Osama bin Laden, and is currently, with this kind of object, is currently at Pakistan. This is how all this intelligence, this is how they work as well, using satellites at times. Okay, we have image annotation examples, both labeled and non-labeled, raw data image. And so you see here, you see this group of, you see these people are on a zebra crossing, and a bicycle and a car, two people crossing. So you see here, you see they are not labeled. And again, you see elephants in a field. And then now you see a lady in a grocery store. And then you see ocean or lake. These are raw. AI cannot understand these images here. These 4 images here, if you give it to AI might not be able to understand it. If you are training, not the AI that is trained. Like if you give it to ChatGPT can read this. But the point I'm making is that if you want to train AI, this is not the best way to, because we are not making, AI is not learning anything from this, because it's not labeled, it's not annotated. But the second, the labeled or the annotated images, you see a car. You see, we use this box, bounding box, and you see a car. You see that person riding a bicycle, we use another bounding box. Then you see another person here, it's a bounding box. You see another bounding box. Then you come to elephants here. You see the way we capture the elephant. Then you see these 3 here. We capture these 3 as well. And we come here, we see this woman in a grocery store, and we've labeled, we say this one is chef, and we say this person, we say product, we label, we add another one, we say cat. Then we'll come to this other natural, this thing, sea area. We capture sky, vegetation, and the water. So this is how you see the way it is labeled. Through this kind of labeling, yeah, this data is very much ready to use for AI training. So these are the things you are going to be expected to do. When you have an image like this, they will ask you to, work on the data, process this data. When you ask to process data, it might use specific label, it might give you specific instruction on what to do. And based on what we've done here, you should be able to know, and again, on the tool we are using, on what to do. But mostly, this is how most images we use. But we can go deeper or advance to want to understand bit by bit. Based on what we've done, we can go deeper to understand even the science and things like that. So this is an example which we can use when we want to do hands-on. there is another template we have here. So yeah, so keep notes. Another template is here for usage. So with this, we can comfortably move to another modal, which is audio annotation. So we've treated text and image. So we're talking about audio. Audio is sound, spoken word. Audio annotation, add label, transcript, timestamp, or speaker information to sound recording. If you see as I'm shaking, you are seeing my head, that at this point I'm video. But once I turn off my camera, you are still hearing my voice. What you are hearing is no longer video, is now audio. You're hearing my voice alone. And you can make a meaning out of my voice alone. So we add label transcripts. You know, all of us know that audio recording is a big money now. As a matter of fact, a lot of companies are looking for people to come record their voice, and you get paid. You know, only your voice, that is audio. And another good money is transcription. A lot of people have been making money through transcription. So these are the first steps if you want to understand audio very well, is to know how to annotate audio. Applications, speech recognition. When we annotate audio very well, we can use it to train AI for speech recognition. Speech recognition, voice assistant. You know, if you come to a lot of household, you see all these baby girls. You know, I'm sorry to say this, but women and soft life is 5 and 6. You know, even to press type something on remote, they can't hardly do it. Alexa, please. Alexa, give me water. Alexa, take me to this. So what is that? Just press it. They say no. Why is Alexa here? You know, because Alexa is trained to understand voices. You know, no matter how big or small that particular AI assistant can recognize their voice, can understand what you are saying. As a matter of fact, you do not need to speak like English people. This speech recognition, they are trained to understand different voices, different accents. So if you come as an African and make your speech as Alexa, Alexa will recognize it, and during the matching, it will see where your speech would. You know that this is an African woman trying to live a baby girl life. Or say, okay, no worries, I'll still serve you. And it will take you to Netflix and get a very beautiful movie for you, you know, or it will take you to YouTube, you know. From YouTube, Alexa, do this on YouTube. You will just go, Alexa, Ruth Kadiri channel. Alexa will go and look for Ruth Kadiri and bring you, Alexa, the latest movie in Ruth Kadiri channel. So, all this is voice recognition, speech recognition, voice assistant, call center analytics, emotion detection, and transcript. So we can use this. As a matter of this, another very powerful topic, and is really giving us a lot of money. These days, you can see that you can make a video of yourself. You clone yourself. How do you clone yourself? You record your voice. The main thing is your voice. You record your voice and add an image. And you tell the AI to dress me in a very beautiful suit. And AI will dress you in a very beautiful suit. And you mount and start, giving motivational speech. You can even become a pastor, dress well, and be preaching Bible, preaching different types of, some people who might not know is, when does Mr. Charles become a pastor? Not just that Mr. Charles is a pastor. Do you see the way he's preaching this Bible? I know this man is an all-rounder. He's even preaching the Bible this way. Oh my God. It's not Mr. Charles. It's just my voice and my image. That's what they just use, and they record, and so that's it. All this is, but all this cannot be happening if there is no audio annotation. So under audio annotation, we have audio classification that assign a category to a sound. An example, speech, music, horn, dog bark, alarm, background noise. So now, as I'm talking now, if you hear background noise from me, you should know that this is not me, it's a background noise. As you are speaking, you might just open up and there's a horn, a car, wow, police siren, wow, wow, wow. You are not going to pay attention to that siren because you know it's a background voice. If you hear me here, you know that there's no way I can be teaching you and I'll be using. So if you hear siren, you know that it's a background voice. So AI should be able to train to understand the real voice, the real speech, the background. Now, if I'm making a speech and there is a sound, a soft music from the background, you should be able to distinguish from the main speech and from the background music. If I'm making a speech and there is a car blow horn, you should be able to understand the horn of a car and the actual speech I'm making. If a door is barking while I'm here teaching, you should be able to know the real tutorial and the sound of a barking dog. And this is where this can become very, very important based on what we are trying to achieve with AI. So that is classification. This is the basic classification. Basic classification is to understand a speech. A speech is different from a music. A music is different from a horn. A horn is different from the sound of an animal. And alarm, when there is alarm, or a phone call. So we should be able to understand these are basic classification of an audio. So speech transcription. Speech transcription converts spoken audios into written text. For instance, here, this is audio. Please reset my account password. The annotation Under the annotation, we say transcript. You have to label it as transcript. Please reset my account password. Yes. So this is the way you annotated this particular audio speech. You annotated it, you assign transcription, and this is transcript. And this is mean that it's being transcribed from this audio record. Speech identification. Speaker identification determines who is speaking. So if we are here in a meeting and this is a recorded meeting, only audio meeting, we recorded an audio meeting, and we want to know who is speaking, we should be able to annotate an audio clip. So, for instance, here you see customer talking to an agent. If we want to make it easier for people to understand, if during the transcription or after, we can say this is customer, the speaker. We can say that the speaker is the customer here. We can say another speaker here is agent. So we should be able to differentiate between when these two people are speaking. Yeah. At times we can equally give ID to speakers. Like this ID, you might, if we have them in a table, we might decide to add a unique identifier to both each speaker, like a customer and agent. Then we have speaker diarization. Speaker diarization determines who speaks at this particular point. How many, if we have a recorded video, recorded audio of, let's say, 1 hour, and we decide to do it clip by clip, so we can say that within the first how many minutes, the person speaking here is the customer. And after that, within the 12 minutes, we have agent speaking. And then you see, we can classify based on the time, we can apportion when every speaker is speaking. Looking at it, so we can use that to, label a particular audio clip. This is important during transcription and meeting. You see this particular class I'm having. So when it's going to be transcribed, the Google Gemini, if I ask Google Gemini to transcribe this, the Google Gemini will be able to get a transcript of this, give how many minutes everybody is speaking on this class, who have spoken, Vivian has spoken, Charles has spoken, Christopher has spoken, Google Gemini and the Charles has spoken. Google Gemini should be able to state when each and every of us made during this 1 hour or 2 hours class, when everybody made a speech or when we speak, and what the speaker said and duration of the speaker. So this is what we call speaker diarization. We have emotional labeling as well. Emotional labeling categorize emotional characteristics within the speech, such as in a speech based on the tone, you can say is happy, is angry, sad, neutral, frustrated. Example here, a customer shouting about a failed payment could be labeled as under emotion here. You say angry or frustration on a voice. So that can be a way to label. So that when AI hears somebody shouting or in that manner, AI automatically know that this person is angry or this person is frustrated. It recognizes the pattern. So when it recognizes the pattern, when it's been trained twice, that this is how angry person, the next time, if he hears that kind of voice, you say, please, what can we do to this angry woman? Yeah, because you know, the person is angry, you've already understood. Yeah. The way to do this kind of labeling is through labeling of using emotional label like happy, angry, sad, neutral. Yeah, that's the emotional label. Yeah. Then we have what we call timestamp annotation. Timestamp annotation record when a particular word, event, or speaker segment occur. So just like what we said earlier, you see here, timestamp, you see here, when did I speak? Within this is timestamped. You know, at this time, this customer begins speaking. At this particular time, mention refund. At this particular time, within the 15th minutes of the speech, of the conversation, agent responded. So if this is an audio clip, we see the way we recorded and the way we label this. This is called timestamp annotation. It's trying to record the actual time and the durations such events happen within the clip. So audio annotation example. So under this, you see, this is how an audio is supposed to look like. You see the first one here in blue container, this blue container is the natural clip, unlabeled clip. So if you come down again, you see the green container contains the labeled one. Under the labeled one, you see we capture speaker one, speaker two, speaker one, speaker two, and speaker one. Yeah, you see them here where they are speaking and when the speaker one is speaking and when the speaker two and when they, so you see it here and the timestamp on each of them. Yeah, you see here, we put transcription, we equally put intent here, we equally put sentiment here, and timestamp. So you see what we use to label them here: transcription, intent, sentiment, and timestamp. Yeah. So you see the way we label this video now, this audio now is easier to understand, and when just looking at it, you might be able to understand what this particular, you've not even listened to this particular clip, but due to the way it's labeled, you can easily understand what this clip is all about. Yeah. So this is another template we can use. when we want to commit on our hands-on, we'll have tangible templates we can look up to and be able to do our work. And then that's bringing us to the end of this audio annotation. So sorry guys, I never planned for this to last up to 2 hours, but it's lasting up to 2 hours. But this is the last out of all the model we are going to talk about, the video annotation. Video annotation applies label across moving visual data. Because video consists of sequence of frames, annotation can involve both what is visible and how objects or activities changes over time within the video. To have what we call video classification. Video classification assign one label to an entire video clip. So the first thing with your annotation is the entire video clip. You start with, so we see here, football match. So you label the video as a football match. You can label it as a traffic scene. You can equally label as customer demonstration or workplace safety incidents. So this is how you label this video too. This has given a name to the entire video, so that before anybody even watches the video, you understand the content of that video without opening the video. So to have what we call frame annotation. Under frame annotation, individual videos are frames. Individual video frames are labeled separately. Example, you see frame 100, pedestrian present. You see frame 101, pedestrian present. Then you see frame 102, pedestrian crossing road. So we label based on video frame. Video frame. All of us, if you know video production, you know what I mean by video frame. Video goes by frame by frame. Object tracking. Object tracking follows the objects across multiple frames. So if we have a particular object, if the object is moving from one frame to another, that object tracking will be following the tracking will help us to follow the object throughout the entire frame, the entire life cycle, or the entire journey. Example, a car appears at frame 1, frame 2, and frame 3, and frame 4. We use object tracking to follow this car all through these 4 objects in a particular video. So with this, the system recognizes that it is the same car moving through the entire video, not another car. It's a particular car. Event annotation. Event annotation in video means it marks when a defined event happens in a video. For instance, car collision, 2 cars coming together, customer enters shop, football, a goal happens, somebody scores a goal, football goal, machine failure, and the person falls. These are events that can happen in a key event in a video. So in a video, you see in this event, this particular team scores a goal. In the entire is a special event within that video. Yeah, something we should be able to label a video when events happen in a video. We use event annotation to give labeling to every activity that happens so that we should be able to treat each event within the video. Maybe you see another event is somebody received a yellow card. Another event could be another person received a red card. These are another event, somebody scores a goal. You know, another event, they remove somebody and brought somebody in. These are different events within that particular video. So we can use this event annotation to label each event, key events. So if you want to discuss this video, that's why you see all these football pundits. It's through this annotation, you see them, if they want to analyze, they will pick an event and the system will just go there to that particular event and grab that event and say that this goal, Jude Bellingham scored, the last goal Jude Bellingham scored against France is a very spectacular goal. And they want to discuss it. They mention that particular event in a video. And it's good, they don't need to, the system will just go directly and pick that particular goal from, and you see them analyze it. It's through event annotation. Activity recognition. Activity annotation identifies what a person or object is doing. Within a football, you can see that some people are running, you can see some people are walking. You can say that Messi didn't do anything, he's just walking around the pitch throughout this match. Because you can see through kind of activity recognition, you see that he's just walking. You see that this guy is just running around everywhere. He's running. So this can be an event. You can see that this is a relay race. This is a sprint. This is a marathon race. This is a boxing. It's called activity recognition. So see here, walking, sitting, driving, picking up an object, fighting, operating equipment. These are different activities within a video. So activity annotation identifies what a person is doing in that video. What is the activity? Activity and the event are very similar as anywhere. So you see here, if you come to video now, you see these are frames. You see under here, you see lines, cutting all this video. We call these frames, video frames. You saw this line, you cut this one, you cut this one, you cut. As the time progressing, so yeah, that is what we call time frame in a video. You see, under 00 time frame or video frame, sorry, frame, call it frame. Under this 00 frame, you see what happened. Under 00.02, under 04, you see what happened. Under 06, under 08. Then, but this is raw. Then you come here, you see it's now labeled. And you see it here under 0, you see here everything. Yeah. So that's what we call time frame. And it can be labeled. Yeah. And label use time frame. The first is video classification. You say you come here, you see frame annotation. Then you see here we use object tracking at this point. And here you use event annotation. And then here we use activity recognition. And within these different labeling stages, something happened. Like now under video classification, we say this is a traffic cell, sports, or surveillance, or tutorial. We can add a name. So, and that's it. So, pay attention to each of these diagrams or these examples we captured. It's going to help you to understand what's happened, you know. So that's what we have for both all these model, call it multi-model. So multi-model annotation comparison. So under this, we see what happened in most cases. When we come to text, most cases in text, we have intent, we have sentiment, we have entities. If you come to images, we have classes, bounding boxes, and segmentation. And then we come to audio, we have transcript, we have speaker, we have emotion. And then we have video, we have objects, we have activities, we have events, and we can equally add more. It's not limited to only these examples. These are just some of the examples we captured here. We can add more. And this is our multimodal. You see here, we capture the text. Here, this is the text. We capture the image, the audio and video annotation. Yeah. So that is it. And that is what is bringing us to the end of this multimodal data annotation. So what we did tonight, we tried to understand what is classification, what is the difference between segment and intent, what is not identified, and what is relationship annotation, what does a bounding box represent, what is different between semantic and instance segmentation, what is key point annotation, what is speech transcription, what is speaker narration, what is object tracking in video, and many more. We learned a lot from this particular class. So a lot is contained here. So that's it. Have the take home or take away from this and the summary of this. Yeah. So I will share the notes as usual because this note is very, very important. So because of all these image templates I added to them. Yeah. So tomorrow we start with tools we are going to use for this annotation. I think we'll have enough knowledge to take us to the practical aspect of it. So the only thing is just like guidelines and the laws and this and that, but the main important thing is now is the tooling and the hands-on, which is going to be the next topic. So if you have any question based on this multimodal data annotation, you can ask your question. And yeah, this is just 2 hours session. It's not big, it's not long, I know. So just that we are 1 hour, we're used to 1 hour lesson, but this is 2 hours. If we start doing it 1 hour, and we might not leave this boot camp. So 1 hour is just like if we're treating them, we're treating text as a topic, then we'll treat image as a topic, then we'll it's fine. All right. Thank you, everyone. Thank you for joining.
Please, thank you, sir. Thank
All
you,
right,
sir. Please,
Mr. Chris.
when you're uploading, please help us to increase the font so that we can see very well, sir. Please.
Okay, no problems.
Okay. Thank you, sir.
All right.
Thank you, sir.
Please, I encourage everyone to equally try to pay attention and read the notes. It's extremely important as well. Yeah, you're going to help us when we're, do what we need to do, share, but it's enough to take us to the practical aspect of it. Yeah.
It's taken, sir. Thank you.
You're welcome.
Thank you, sir. Good night.
All right, everyone.
God bless you.
Thank you, sir. Good night.
Good night.
John Peter, good night.
Thank you.
Good night.
Yeah.